Okay, in this table we have what transformations will actually do to a function. So what you typically do is you start with a function that you know what the graph looks like. If you don't, you just plot, some points and say, okay, at 1, you'd be at 1, 1, and you'd be at -1, you'd be at 1. Get that off there. And then at 2, you'd be at 4, and then -2, 4, and so on. So this is going to be ugly, but we have our parabola here. Didn't even make it through that point. You know what you do when you don't make it through a point? You make your point bigger. All right. So, and then they come back and they say, well, what if we took that function and we subtracted 3? What would that do? Well, if I look right here, that would shift the function down 3 units. So I would just simply pick it up. I'm at 0, so I'd just simply pick it up, and that would shift that graph. I never said I was an artist. That would shift that graph down. And we could continue with this. Well, what if we had another function based off of this where it's x minus 7 squared? All right, well, that looks like this one. So that would shift it to the right. Okay, going back, starting with our original function. I wonder if it'll let me just, let's see if it'll just, oh no, we don't want to do that. Starting with my original function, I would just pick it up and move it over here to the right 7 units, and then I'd have my parabola. If we had something like maybe, thinking of another letter, how about L of x? We had something maybe like with a negative out front, and then x minus 4 squared. Well, this once again would shift it 4 units to the right, but then what that negative is going to do is reflect it about the, reflect it about the x-axis. So it's going to shift the black one, my original, it's going to shift that to the right, but then it's going to flip it upside down, and that's what it means by reflecting about the x-axis.